Good morning, everyone. My name is Dani Golan. I'm the CEO and founder of Kaminario, and I'm excited to be here. Although it's 8 o'clock in the morning, who does technology meeting at 8 o'clock in the morning?
Just
I was surprised that everyone was on time, but I'm really excited to be here. We have a deep dive on Kaminario today. Actually, you don't need me dressed, right? It's
I love it.
Thank you. We have here Ritu Giotti, our VP of Product and Solutions, and Gareth Tao, our VP of Marketing, with me, and hopefully we can answer all your questions about Kaminario. Let me start with how we started. Okay. We started the company in early 2008 with two fundamental understanding. Basically, with the introduction of solid state, we understood that this is a game changer for the storage world. This is not a new niche. This is not a new segment. This is the next generation storage. My personal opinion that this is the biggest revolution in the storage world in the last 30 years. I think it's one of the biggest in the IT since virtualization because it changes everything. We will talk about our beliefs more in depth next, but fundamentally, if you all believe that solid state would be the predominant capacities for active data, essentially there are two assumptions that we started and are still valid. First, you need a very different architecture to handle solid state than rotational disks. That architecture is a scale-out architecture. The monolithical architecture that pretty much all of the legacy high-end storage have will not work well with solid state. The second premises that we started the company is that all the software stack, the rich software stack that exists today, very competent for hard drives, will not work well or sometimes will not work at all in all solid state environment. What we have built is an all solid state SAN storage, but not less important, a full enterprise data protection stack. Without that, you're not a storage, right? You could be an accelerators, you can be many things, but you're not enterprise storage. And we will dive into both the architecture and what we did with the software stack. Let me tell you that storage is hard. I've spent most of my career in the storage business, many years at EMC. I can show you the scars on my back from Wall Street customers. You need to know what you're doing in storage. This is why from the beginning we assembled some of the best talents out there from the storage business. And we feel that we're quite unique in that perspective, that the amount of talent that we aggregated from the storage world. Ritu came for many years at EMC as well. She ran worldwide solutions at EMC. Our VP of engineering was the chief software architect at IBM Storage. I always like to joke that between him and me, we have 45 storage patents. Now, obviously, he has 90% of it, but still, we have a lot of storage knowledge when we started, and we had the perspective on what worked and what didn't work in legacy storage. Fundamentally, our belief is that solid state will replace HDDs in active data. Okay, you can predict how aggressive it would be, but basically, active data will reside on solid state. And here is a question for you guys. What is high-end anymore? All of a sudden, if you look at IDC, they have 9 price bands. All of a sudden, with a $100,000 box, all solid state box, you have an order of magnitude better performance. I will show you that the software stack is far superior than a $3 million array, high-end array. This trend of all solid state storage flips the pyramid, in my mind, on its head. All of a sudden, how do you measure this market? This is why I think it's so disruptive to not just a niche of high performance, but to all of the roughly $80 billion storage market. And as I stated, it's about the right architecture, and it's about the right software stack. We started, as I mentioned, quite early. From the software folks, we probably the earliest of all in 2008. We have been shipping commercially for the last actually more than 18 months, 20 months, and you know how important it is to harden your product in customer environments. It's completely different from your labs. And I think the best way is to start by a very short video. I apologize. Let me quickly stop it. This is our system on the left here. This is a Kaminario, the scale-out architecture with blades. In this case, it's rather small system. It's an 8-blade system. And what you'll see here is, in a very short clip, the 2 elements that we have been talking about. 1, the scale-out architecture, and 2, the enterprise ability that is what we think very different from the legacy storage.
So you do need a chassis for it? It comes in a chassis form factor?
It comes in an enclosure, yes, but you can start very small and fill it up, right? And it's multi-enclosures, etc. So it's span across. What you see here, this is our GUI. You have throughput, IOPS, latency, and I apologize for the resolution, but what you see here is a 500,000 IOPS, the smallest machine that we have. And what we're going to do right now, I'm not here to show you performance. Okay, what I'm here to show you is the enterprise capabilities. What we do while we're running 500,000 IOPS, we're pulling one of the blades. Obviously, this is a blade that's full of capacity. We just pull it midstream. Okay, so this is obviously one of the most severe malfunctions that you could have. It's not a disk fails, it's not a card fails, it's the whole entity goes away. And let's see what
So Dan, each blade has a controller, logic, and storage?
Yes. It's a full scale-out architecture. So
it also supports the host interfaces as well?
Yes, yes. So essentially, don't think of it as a controller. It's fully distributed, okay? Every one of those entities, physical entities, could have connectivity to the host or not. It depends on how much performance you want, what are the characteristics of the performance that you need, and we'll talk about it later more in depth.
It would help the guys if we just cop to the fact that they're Dell Blade servers now.
Yes, yes. I want to emphasize 100% software company, right? We're running on an off-the-shelf hardware, and frankly, we don't care what we're running on.
So if you want to use it on other components?
Not a problem.
Okay.
Not a
But-
problem.
so
Now, obviously, we
you're-
qualify. We don't allow customers to run it on any hardware that they want. We're very carefully qualifying the hardware. But to your question, it's agnostic to the hardware we're running on.
Danny, were you suggesting
Yes.
that as you scale out, you could scale out just capacity and performance if you wanted to without host interconnects, or if you needed more host interconnects, you can scale them out as well?
So if you want to add just capacity, you can. If you want to add just performance, you can, okay? And that usually dictates more paths to the host. Right? That's a good rule of thumb.
And it's fiber channel.
Fiber channel, yes. Yeah. We don't have, our philosophy is that we will give any connectivity that the customer needs. Predominantly, customers are asking for fiber channel.
Could you deploy, whether it's Dell or HP, like half your chassis with these SSD boxes and the other half compute, and kind of scale it out that way?
The answer is yes. Okay. This is not something that we pre-qualify, right? But as you'll see in a moment in the architecture, there is nothing that limits us to do so. It's an x86.
Kind of keep it on the back plane of the chassis.
Now, I want to show you what's happening from now. So we pulled one of the blades, catastrophic failover. Obviously, everything goes to zero, while our operating system, which we call Spear, figures out what happens. Very quickly, you can see it's real time. A matter of a few seconds, we start to serve again the I/O to the host. In a matter of 10, 12 seconds, we're back to 80% of the previous.
Yeah, but if you actually
Performance.
go to 0 for 10 seconds.
No, we're going to zero. It was only a few seconds, right?
Yeah,
And-
It's about 10
but,
seconds.
but even if it's 5 seconds, that's enough for applications to start failing.
So we are, and this is something that we're making sure in our qualification labs, that we're under the threshold of pretty much up until now. Maybe there are applications out there that are much more sensitive, but up until now, all the OLTP and all app applications that we encountered were way above our threshold.
Okay. Now,
Just let me
ahead.
quickly finish this. The recovery time and performance of the recovery are far superior than any legacy storage out there. So what you've just seen, that in a matter of 10, 15 seconds, we're up to 80, 90% of the original performance. Right? We're keeping the SLA. In legacy storage, you can go down to 5, 10% of your original, and that's for mission critical application is devastating, right? As storage admin, as storage managers and directors, you have to guarantee SLA to your application customers, okay, at all scenarios, including the most severe failures. That this is probably one of the most severe failures that can happen. And we guarantee that. So our customers are not asking us, hey, show us your best performance, right? It's clear SSD is fast, right? I promised Ritu I won't tell, so I won't, but we're in a process of breaking few world records of performance, some very familiar benchmarks, not in 10, 20%, at a very significant margin. That's not the issue. The issue here is that under any circumstances, we give the customer the SLA that they promise to their customers, the application, the database that are running on this storage. That's number one. Number two, it's very consistent. Okay, what you'll see in the architecture, what we do essentially is we spread the performance very, very effectively.
Is the management totally unrelated to the underlying hardware?
Yes. Yes.
I just worry if you weren't a Dell shop or if you're running UCS, then you're like, well, now I have this other box that I need to manage totally different.
It's statistically, as you know, take Fortune 3000. I think if not 100%, 99% of them have multi-vendor strategy, right? So we get in and we have our own very elaborate management console, but we absolutely hook up to the enterprise management scheme. So it's transparent to run Kaminario and manage it. And what you'll see is extremely simple. Everything is automated. You don't have to decide anything in terms of performance, data allocation, and I'll show you in a moment how we do that. So it's not a black box from that perspective. Now, so this is the failure and the recovery and how dramatically different it is from legacy architecture. Another element that I want to show you is the non-disruptive operation. Okay, so now we have a failed part that we took out. What the last part of the movie is we're putting it back in. Now this is obviously healthy hardware, right? So we just took it out. We're putting it back in. The operating system identifies it as a healthy part, adds it back to the pool online. You don't have to take the box down. All the operations are online. That's extremely important to enterprise customers. By the way, one nice statistics, it took EMC 16 years to be fully non-disruptive. It took Kaminario 4.5 years to get there. And this is achievement that we're very proud of.
Those blades going in, are they just all internal storage then?
Yes. Everything is in the hardware entity.
So the blade itself holds the SSDs?
Yes. So let's talk about the principles of the architecture, and then we'll dive in each and every one of the rectangle. A true scale-out architecture. And the emphasis here, it's a granular scale-out architecture. The trick with SSD, since it's so competent, is that you have to have enough CPU and enough network to extract the performance out of it. And so we're finally graining the scale out. You cannot have very thick entities and expect to get a lot of performance. So we took the big problem and we broke it to many little pieces.
If you talk granular, how flexible is that according to sizes of SSDs? Can you put in, for example, next year the new types of SSDs coming out, bigger types of SSDs? Is it in the same array that they're going?
You know why I'm smiling. There is a you know what's the difference between a good question and an excellent question? A good question, I have an answer. An excellent question, I have a slide. So this is an excellent question. I have a slide, and actually it's part of the animation. We are 100% software company, and as such, it was very important for us to be virtualized completely from any hardware component. So we are x86 platform, and we use the best of breed media, the best of breed networking, and if tomorrow there is a new thing, we can use it. The last element here is the solid state media of choice. We essentially allow the customer to use different SLAs inside the SSD. We're letting them use DRAM, PCIe flash, and SAS or SATA interface flash. And it all depends on the price point, the performance characteristics, and the behavior of their environment. Lastly, the data protect element, which if you look just the amount of energy that we put in, I think that 2/3 of our patents are here. And let me run through all of them. Basically, an enterprise storage, not an SSD enterprise storage, needs these elements. Now, these elements, then we'll talk about in a moment, needed to be finely tuned for the new media, solid state, just new speeds. First one, self-healing, high availability. Everything needs to be automated. Nothing is handled by an admin or an operator. Everything is being done by the Spear architecture. Everything is thin provisioned, fully non-disruptive, and high-speed snapshots and replication. We will talk more in length on snapshots, but I just want to give you an understanding what are we talking about in terms of difference. Today, a legacy storage, any of the high end, if you do a snap, it will take you anywhere between 5 to 10 seconds. It depends on the capacity, by the way. To take a snap in Kaminario, it takes 10 milliseconds. So 2.5 orders of magnitude. So that's dramatically different. When you're running a high-performance environment, and we've seen that in customers again and again and again, that the irony is that in the most critical environment, when they needed performance, they could not use the legacy snapshots. With us, all of a sudden, they can do that. And as you know, snapshots is probably the most important software, storage software from operational point of view. This is the heart of probably any operation. Any questions?
How are you doing the snaps?
I'm sorry?
What's the idea behind the snapshots?
So we're going to. This is
another slide.
Another excellent question. Yes, we have actually a few slides on it.
Danny,
Yes.
yesterday at this symposium there was a lot of talk about compression and deduplication. Do you do that, and do you have an opinion on that?
Absolutely an important element of efficiency, and this is something that we will do in the future. In terms of our priorities, customers told us this is important, but I will not run mission critical applications if you don't have snapshots, replication, non-disruptive operation. So the customers said, we want dedupe, we want compression from you, but it's secondary to the data protect elements that we came out first. Nigel, to your previous question, you can add capacity by itself, you can add performance by adding more connectivity, which is essentially, think of it as the pipe to access the data, and that's independent. So what the customers are getting from Kaminario is exactly what they need. They don't need to over-provision capacity. They don't need to over-provision connectivity. They get exactly what they need. And if they want to grow, they can do it online, separately, capacity and performance.
Danny, you said that the SSD media can be DRAM, PCIe, SAS, or SATA. So you support drive shelves, or is that all on that blade?
It's all in the blade.
It's all on the blade. So
Yes.
whatever they do. So how much can they actually fit on a blade?
It's it can fit 2 PCIe, and 6 disks.
2 PCIe and what was the other one?
6 disks.
Different disks
Disk
in
slot.
the same array.
Yes.
Different technologies of disks?
Yes.
MLC, SLC?
Yes.
Okay.
This is a good question. Because of our architecture and the fact that we distribute the data very effectively, we didn't believe that SLC is the right way to go. We skipped completely to MLC. We don't sell SLC, and you'll see why. A lot of the endurance we do on a system level, and a lot of the consistency of performance we do on a system level. So we skipped SLC altogether.
Danny, it's an interesting thing that you said about the data protection and the NDU are more important to you and to your customers than dedupe and compression. I think yesterday at the symposium there was a lot, or it was quite clear that some of the vendors there were gunning for ultra high performance like violin memory. Some were aiming at the cloud. Where do you see your market and where do you see your customers? You know, do you see yourself as a SIM killer or as a cloud appliance or what?
Yes. So we're aiming at the enterprise market. That's our focus. And obviously the enterprise market, if you take Fortune 5000, they have very diverse needs. So it was very important for us to go and develop the fundamental capabilities first, which is the scale-out architecture and the data protect elements, so we can fit in mission-critical environment, OLTP, OLAP, we can fit in virtual environment. Customers today, some of the databases or applications are running on physical servers and some of them are on virtual servers. We have to certainly provide solutions to both. And obviously the cloud, whether it's private or public, is part of any enterprise today. So, but we absolutely focus on the enterprise as our primary market. Any other questions?
Quick question out.
Yes.
When you were building this out, were you aiming at specific customers? Sort of a focus group kind of model to set your priorities, or were you basing this on an analysis of the market, or?
So I would say that we probably by now, since we were very early to market, what we did is the following. I think that we've talked and we interact with hundreds of customers. And I would say 80% of them are enterprise customers. I would say 100 million to a billion or a few $1 billion. And 20% of them were Fortune 500, so the larger customers. But the biggest surprise, you know what it was? Startups, small companies. All of a sudden, customers that didn't have SAN, customers that could never dream of going and buying Symmetrics or Shark or Hitachi, all of a sudden they can get dramatically different performance at no skill level, right? It takes end-to-end 4 hours to implement Kaminario. Why? Because everything is automatic. You don't do anything. And that for less skilled IT is absolutely amazing. So this is when we started in 2008, I probably wouldn't have imagined that we'll have such an attraction that low. This is why I say that the whole storage market is flipping on its head, because all of a sudden, how do you judge this, right? What is it? Is this high end? Is this mid range? Is this? This is why I don't like to characterize solid state as tier 0 or ultra high performance. You know what? We have a saying in the company that every customer on earth needs at least one Kaminario. Everyone has one application, right? That if you accelerate that application or that environment, you'll either generate more revenue or save cost. It could be an internet startup that their main application, is generating the revenue to the company. You know what? Even if you're a $50 million company, you will spend that $100,000 to $150,000 because the ROI on that is so powerful.
Kind of one problem I see is that the densities would be low in kind of a software-based system like this. You're not able to really plug a lot of SSDs because you're relying on off-the-shelf server hardware.
Mm-hmm.
What's your kind of take on that?
So I think the good news is from what I know of all solid state, we're the only one that are using PCIe, and the densities in PCIe are far better than in SAS and SATA. So we are able to get to quite a nice. So we're riding the curve. Every time a new density, right, is coming along, right, and we can use it. Take an example. Fusion IO came out with new cards. We plugged it in as an example, right, and immediately we doubled our density. So that's the power of being a software play. That's the power of being basing on standard off-the-shelf hardware. The cycles of development and new generations are much faster. For us, it's literally just qualifying. We're not changing our software.
Thank you.
I've just got a question that came in from Twitter actually. Somebody's asking about server I/O virtualization and what's your take on that. It's asked, with PCIe connectivity, Kaminario could be server attached memory and not network solid state storage array. Any thoughts on that?
So if I understand the second part of the question, are we PCIe connected to the server?
So he knows that you're not, but
Yes.
he wants to know what your take is on that and why you aren't.
Okay, so we're SAN storage. Okay, that's our primary focus. Okay, I'm not saying there isn't an absolutely great market for essentially direct. Now look at the history. The history for the last 20 years is that storage was 2/3, let's say 15 years, 2/3 external, right, and a third was always internal. So I think the internal started to move to SSD much faster than the SAN market, but I look at this market and it will maintain the same balance in my mind. There is certainly use cases where sitting very close to the CPU is the right thing to do, and all the advantages of SAN still exist in this market. The consolidation, the protection, the high availability, all your mission critical applications sitting in one place, all of that has not changed. This is why both of those models will continue to be valid, and the SAN market will continue to be, in my mind, 2/3 of this $80 billion market. Okay, let's talk about the Spear architecture features. The first two I alluded earlier. Essentially, if you think about the scale-out architecture, think of it as a grid in a box. What we do is we spread the load across all nodes. And the mission of the operating system is, on one hand, not to have hotspots. So if we have hotspots, we eliminate that and we redistribute the data, but we don't want idle spot as well, right? You don't want to have half of your hardware sitting idle while half is working very hard. So we take all the load and we chunk it, actually quite in a very sophisticated way, and redistribute it across all nodes. And by doing that, we're eliminating hotspots, but also we're improving latency, throughput. All the metrics are improved. On the data protect front, as I said, high availability is the fundamental. And our high availability is self-healing. Everything is automatic. You don't have to do anything in good path or in bad path. All the failures are automatic. You've seen the movie far faster than any legacy storage out there, and far better in terms of performance. And for enterprise customers, one of the most important elements is the non-disruptive operation. Absolutely crucial to have non-disruptive operation at all scenarios, and we'll deep dive later on this element. And all the data services that you're used to from the HDD world has to be completely different in terms of performance. The mirroring, the striping, the snapshots, the replication, the thin provision, everything has to work in dramatically different workload.
Okay.
So, please.
Are you writing, or did you write your own load balancing?
Absolutely. This is
And
our own
MPIO
load balancing.
drivers too?
I'm sorry?
Did you write your own MPIO drivers too or not?
Yes.
So how? Okay.
Yes.
So for in the ESX, in the Hyper-V service, you will
So-
have your own MPIO.
Yes.
Okay.
So just to summarize the first part, okay, all solid state SAN storage, obviously it's about performance, but in order to get there, in our mind, scale out architecture is the right way to go, and customer demands full data protection that has to be completely rewritten to the new speeds, high availability and non-disruptive operations and upgrade, and the ability to essentially grow with technology. Tomorrow you have new form factors, tomorrow you have new types of solid state media. As a software play, you can absolutely absorb those improvements in technology quite well.
Danny,
Yes.
are there any common operations that are not non-disruptive at the moment? So you showed the popping a blade or a failed blade, so you have some, but is there anything that I might do day to day, or that might happen day to day, flapping links or firmware upgrades or things like that are
So
identified?
probably the only thing that is not fully non-disruptive today and will be literally in a matter of a couple of months is firmware updates and hardware updates in the K node, the data nodes, where you have capacity. But that's the last thing that is left in the non-disruptive element. Everything else is there.
If we combine the fact that you can choose whatever technology off the shelf that you put on, and you have designed your own MPIO, does it look for the lowest latency to write to? Because if you use different SSDs, different amount of SSDs or sizes, you will have a different latency on each
Yes.
component.
Yes. You do that not by judging latency, but the depth of your lists and queues. But basically, it's the same. With that, yes,
I'll
please.
throw one more quick one out there
Yes.
in terms of the hardware. If somebody wanted to run on multiple hardware platforms, say Dell and HP, or something like that, how does your system support that, if at all? Or
So it's not blended in one system, but
okay,
so
Well, are you supporting anything but Dell right now?
right now,
So,
Yeah.
so today it's a Dell product. Yeah, it's Dell hardware. Theoretically, runs on anything.
yeah, you mentioned having qualified hardware. So is one enclosure a system, and that's the boundary?
no, absolutely
Okay.
not. So you can scale. We have systems in the field with dozens of entities, right? So dozens, and so it scales across enclosures and across racks, right? It's a spanning tree networking, and that's it.
Okay.
So the scale out architecture is unlimited. Obviously, we qualify. We didn't qualify, infinity, but
What would it
certainly.
take? What would it take to qualify another type of rack server or a blade server?
Very easy, and I'll keep it to the second half
Okay.
of the presentation.
Can I just ask one question on what we've
Absolutely.
seen so far? On your presentation, when you pulled the blade, all of the I/O stopped for the whole box.
Yes. So what the system does in that few seconds is assess the situation. It could be a general electricity failure. It could be many scenarios, right? So the box needs to assess what is the situation, and that takes very short time. And as soon as our Spear operating system understand that this is the blade, nothing else happened, we continue the I/O.
Okay, so if you scale out to more than one chassis, 2, 3, 4 chassis, if any of those blades get pulled, does that mean the whole of the environment stops as well?
Again, it depends if it's one system or not. If it's one system, okay, we freeze the operation, okay,
Of the entire environment?
of the entire environment and continue. Again, I want to stress that all the environments that we've encountered till now, and we're talking about hundreds, we didn't have a single environment or application that it was too long for that environment. And you want it to be, this is by the way not different from legacy storage, you want to assess the situation. You don't want to have corruption, you don't want to have any problem. You want to if there is a catastrophic event like general electricity failure, you want to gracefully shut down your box. So you want to make sure that first and foremost you're not creating any scenario of data loss, right, or data corruption.
So I remember seeing a 3-part presentation a couple of years ago where they did the same thing, and they had an 8-node setup, and they just pulled one node, and they lost a percentage of the I/O, but the boxes didn't stop, they carried on running.
Yeah.
So you lost a percentage and then it went back up again as it rebalanced.
Yeah.
So everything kept running, but only the performance on the box, the component that went down was lost,
Yeah.
not the whole lot going down.
Yeah. So it goes away for very short time, but as you saw, it immediately goes down, not to you immediately go to 80-90% of what you were, very fast.
What's your cluster interconnect? If you've got multiple chassis, is it fiber channel or?
So outside it's fiber channel, internally is 10 gig Ethernet.
And that's 10 base KR across the chassis platform too.
Yes,
right?
of course. So with that, I want to thank you all